algorithm. So today also a small topic with that I will wind up this binary search. Sir, very simple. We are discussing about the searching techniques. We have two types of searching techniques are there. One is linear search, another one is a binary search. In the linear search, how we can able to search for the element we discussed, and even we have seen how we can able to search for the first occurrence and second occurrence, and in the same linear search how you can able to find all occurrences we discussed, and we have implemented a program to return the last occurrence, and even we know binary search algorithm we implemented. In the binary search algorithm, how to search for the element by using iteration, that is by using loops. How we can able to search for an element by using recursion we discussed. In that, how to search for the element in the first half and how to search for the element in the second half we discussed very clearly. So now I need to take the same program, but I want to do the customized sorting, sir. I mean customized range of values, like implement a binary search algorithm to search for an element. So in the given range, I'm going to provide the range of values. In that we have to search. Let us see how we can implement this particular program. So now I'm taking binary search 3, or let it be binary search. So here what we have to do, you need to search for the data in the given range. So in addition to key, we need to read starting value. So from where you have to search it. So I'm taking, so enter start value of search. So then I'm going to read ending value of the search also. So I'm giving end is equal to, so enter end value of search. So what I'm going to give in the list, starting from this particular location to starting from this particular location to ending this particular location I'm taking. In between this, we need to search for the data, right? Now let us execute this code and cross check how it is going to work. Sir, I am running the program py space test.py. So enter the value which you want to search. Consider I want to search for the value called 60. So what is the starting value of the search? That means in which location you are trying to search. Assume starting location is a 0, ending location is a 3. So in between this 0, 1, 2, 3, in between these values, is the number 60 is available? No. Suppose consider I want to search for 20 in between 0 to 3. Is it available? Yes. Now consider I want to search for 70 in between the locations 0, 1, 2, 3. So third location to eighth location. Yes, it is available. So the value which is available at which location? The location number 6. So like you can do customization in the sense, in between which locations we are searching for data, simply we can able to get by using this particular algorithm. I think friends, you people got very clear idea how we can able to work with these algorithms. Everyone please confirm, is the concept is clear up to this whatever I covered?
Yeah.
Yes, I am requesting every student to please respond.
Yes, sir. Clear.
Clear up to this whatever I covered?
Yes, sir. Yes, sir. Clear.
Right. Good. So this is nothing but how we can able to perform different ways of searching algorithms. So next, there are some applications are there on this. Let us cover. What is our next application is, sir, I want to find the number of occurrences, the number of occurrences of the given object, the number of occurrences of the given object in sorted list. So I'm going to take a sorted list. In that, how many times that particular element is available, you have to find. For example, consider I have a list like so 10, 20, 20, 20, and then 30, 30. So I want to search for the element called 20. How many times it is available? 3 times. Suppose consider I have a list is there with the elements. So 10, 10, 10, 10. How many times the element 10 is available, sir? It is available 4 times. So now consider I have a list is there with the elements. So 5, next and after that 8, next and after that 10. Assume I want to search for the element called 7. How many times it is available? It is not there. 0 times it is available. This is my target. Sir, seems to be the problem is very simple. What we have to do? You need to search for the element. There are two ways are there, sir. Okay, there are two ways are there. What is the first way here is, we are going with a linear approach. Okay, so method 1 I am taking. Method 1 I am taking. We are going with a linear approach. Like, so we are going to define a function called count, where I will pass a list and then the element which you want to search. Sir, count is equal to initially 0. For each I value in the list, if the value of key is double equal to my item, then count will become count plus 1. At last, I will return the value of count. That's all right. And in the print function, I'm going to give in the formatted string. So this is nothing but my list. Okay, this is nothing but my list. And the element which I want to search is nothing but a 20. So in this case, what is the output that we are expecting? In the formatted string, I am calling count function by passing the list, comma, key. So here we have the list is there. Can I say this is my list and this is my number? Right. So this is nothing but what we have. So now my requirement is, I want to search for this particular data. How many times it is appeared? Perfect. So let us run this code and check how many times it is appearing. Fy it is coming. I think here we can remove. Now you can see 3 times 20 is available. Sir, can I rewrite this program for another example, whatever we have taken? Like, what is another list that we have taken? 4 tens, and we are searching for 10. 4 tens and we are searching for 10. So 4 tens and we are searching for 10. And in the next list, 5, 8, 10, and we are searching for 7. And we are searching for 7. Assume this is nothing but the content what I have. Sir, I want to execute this code. Yes, for all possible cases, it is working. Sir, what is the time complexity of this? Compulsory, you have to check each and every element, right? Then only you will get the result. Sir, I have another method is there for this. What is this method is? Sir, very simple. I am going to implement this method. First, I will find out first occurrence of the given element. Okay, first occurrence of this particular list, comma, key. In this list, so where it is available, that first occurrence I am trying to return. Sir, somewhere in our previous videos, we discussed how to find out the first occurrence of the given element, right? So some function is available. I can say this is the function. I am taking this function, linear search. Okay, let it be. the function name I'm checking like this. First occurrence it is going to return. Now I'm going to verify if your first occurrence is equal to -1. That means that element is not available. Just I'm going to return 0. Otherwise, I'm going to find out the last occurrence of the list. I mean this key element minus a first occurrence. So minus a first occurrence plus 1 is nothing but my result, sir. So how you can able to find out the last occurrence somewhere? That algorithm also we implemented last occurrence. This is the algorithm for last occurrence. Sir, since the data is in sorted order, you can see. Suppose consider I am searching for the element called 10, 20, 20, 20, 30 and then 30. We are searching for the element called key is equal to 20. How I am going to identify 0th location, first, second, third, fourth, fifth? Sir, what is the logic here is very simple. We are identifying the first occurrence value, index value, first occurrence. It is 1. Last occurrence value, it is a 3. So 3 minus 1 plus 3 minus 1 plus 1. So 3 minus 1 is 2, 2 plus 1 is 3. So 3 times this particular element is available because last occurrence, first occurrence difference is going to return the number of times it is available, but it will return the index count. That's why if you add plus 1, then exact number of items, how many times it is available, it is going to return. That's all. That is the technique what I am using here. Sir, here is it required to find any loop? No. That's why the number of comparisons are going to be reduced. Sir, here somewhere unsupported operand for list and int. Somewhere it is returning the list value. So that is the problem here. How you can able to overcome this? So we have to write a manual code for this, for returning the last occurrence. How we can able to do? It is going to return the last occurrence. Sir, I think the problem will come only for this case, right? Let us comment this and try. Now in the first case also it is coming. Already the data is in sorted order. Sir, is there any problem with the first occurrence, last occurrence method? Can you please confirm?
Sir, line number 18 is returning a list and you are subtracting and adding integer to it.
Yeah, that's what. But in this list, it is returning the last element alone, right? Because of this slice operator, it is maybe taking like that.
Can you do one thing, sir? Can you write line number 12? Can you convert that to integer?
No. Better we will copy into one variable and we will return. I think so. Last occurrence return type is it is taking still in the form of list. No, it is same thing. We can't convert it into integer, sir. We can't convert. So here we will get the last item only, right? Okay, I will do one thing otherwise. So I want to take a list. Can I do like this? For I in the range of starting from -1 to minus of length of the list plus 1, comma step value is -1. Whenever that element is found, can you please return the value of I? Can I take like this? Let us cross check. Last occurrence, it is going to return in the form of negative number. So 10 comma 10 comma 10, if I am giving 0 1 2 Index negative values -1, -2, -3. So when we are calling last occurrence, it is going to return this particular value as a -1. But we need output as -2. Can I take 3 - 1 and 3 - 2? Sorry. 3 - 1, 3 - 2, 3 - 3. Can I take n minus that index? Let me try. N minus this particular. What is the n value here? Length of the list. Now is it going to give the correct output? Oh, we are getting different output. No, something is wrong here. Okay, sir, we will see this later, but I think you got the logic right. So how we can
Sir,
able
one
to find?
solution is there.
What is that?
For we need to write for x in TL that thing return x. Line
No,
number
it
12.
will, it
Line
will,
number 12 for x in that one colon. After that return x.
so
Can you
give
tell
me
me,
a
sir?
return. Yeah, we will see that. Now is it coming? I think so. Right. Yeah, anyway, in that list, we have only one element is there. We can do like this. Yeah, correct. So this is the way how we can able to find out the last element. I mean, how many times this particular element is available. So just we have one methodology is there, sir. I think you people got very clear clarity how we can able to use this in the second method. Can you please confirm is these two methods are clear for you people? So make sure that in the problem statement itself they have given. So how many, all these objects are already sorted in ascending order. Then we have to find out how many times that particular element is available. Please confirm everyone, is the concept is clear? Yes, please confirm, is the concept is clear up to this whatever I covered?
Yes, sir.
Right. So this is nothing but how we can able to implement these searching algorithms, different types of searching algorithms like linear search and then binary search. So you people got very clear idea about how we can work with a linear search algorithm and a binary search algorithm. One or two applications I covered. So with this sorting, searching, divide and conquer got finished. Any doubts, friends, up to this? Please confirm. Any doubts up to this? Please confirm, everyone.
No, sir.
Right. So today I'm going to stop this session. Okay. So we will start this linked list tomorrow class. And one more information for you people. Linked list is a very difficult topic. I need to cover this linked list concept at a stretch. That's why I request everyone to please join tomorrow's session. So at 7:30. Okay. So tomorrow we are going to see the class from 7:30 p.m. to 9 p.m. 1.5 hour session I am going to take tomorrow. Okay. I request everyone to please attend at 7:30. So I will ping the same information in the group also, because it will be easy for me for making the continuity of this linked list. Ashish, can you please be on mute? So this is nothing but our tomorrow's plan. So please join at 7:30. 7:30 to 9 I am going to take. Maybe if time permits, tomorrow and the day after tomorrow, both the days I am going to take 1.5 hour session to cover this what you can call linked list concept. That's why I request everyone to please attend tomorrow at 7:30. Okay. Right,
Okay.
sir.
Yes, sir.
I will upload the running notes within a few minutes. You can download and you can practice. Okay. Right, sir. Thank you.
Thank you, sir.